it's Ripadip here, and I'm going to show you how to study 6th grade science earthquakes. Yay! And so some basic tips just before you start studying is to get comfy, like in pajamas. Don't have your hair in your face. Be with a certain cuddly puppy, and just be ready to study. Okay, so right now what we're studying is earthquakes. So you need to know the basics, you need to know like what happens after earthquakes, you need to know what to do during earthquakes, you need to know like the outcomes of earthquakes. So right now we're just studying earthquakes and plate boundaries. So plate boundaries are, if you learned about them in lesson 5, they're basically just, they're in the middle of faults, so they're what the fault outlines. And when they move, that causes an earthquake. And so our earthquake is just the movement of the land. So if you ever experience it, it's like there's someone shaking the land and you're just on top of it. So if you get down to what an earthquake is, it's basically what happens. So elastic strain, it's stored and you have a rubber band. And so when you stretch the rubber band, what happens when you stretch the rubber band? It builds up all that energy, and when it builds up the energy, then and it finally snaps, it lets go of all that energy, and that's what happens during an earthquake. And so you can tell what an earthquake is so an earthquake starts at something called a focus, and so like if you just like imagine all the land, and then like if just like in the middle of the land, like deep into it, there's a little dot, and that's called the focus. And then there are seismic waves, and the seismic waves are just spread out from this focus all over the land. And when it spreads out, that's where the earthquake is. So wherever it spreads out, and the earthquake gets smaller and smaller as it spreads out. So like if it was right here, then it would be really, really big. And if it went like this and this and this and this, right here would be much smaller than right here. So, okay. So basically what it is there's something called an epicenter, and it's like directly above this focus, and it's on the surface, and like it's where we actually feel it. So, now there are things called waves. So they are in the seismic waves, and there are 3 types of it. So there's primary waves, and they are first when they get first detected, and it's basically like pushing, so like it's like that. And then there are S waves, and so S waves are like this, and so like if we're pushing it, it would be like that. And they can only travel through solids, and then they're the second one to get there because, and so S waves, they only travel through solids, and they are the second to get there because S stands for secondary. And then there are surface waves, and surface waves, they're on the surface, and they're mixed between P waves and S waves. And so it's like this, except you're still pushing, so it's like that. And it's kind of like in a loop-de-loop, like that. And they're the worst because they're the last to be detected, so you don't really know that far in advance when they're coming. So then there are like details, like there's a shadow zone, and the shadow zone is where like there aren't earthquakes, and that's the safest place to be, etc. And then this is actually a really good diagram. So if you look up close, right here, right there, it explains that. So it goes. The surface wave goes along the surface, and then the primary wave and the secondary wave, they go along here, and then the primary wave gets first, and then the secondary wave gets second. So, okay, and so that's basically all you need to know about seismic waves, like the types of it and all that. So, okay, so now there are ways of measuring earthquakes. So there are the actual machine is called a seismograph, and so just imagine like the ground shakes, and then there's a little ball, and the ball shakes with it. So when the ball shakes, that's how big the earthquake is. So if the ball shakes a teeny bit, then the earthquake was really small. But if the ball shakes a big amount, then the earthquake was huge. So it's writing it on something, and that something is like paper. And when you print it out, then that's called a seismogram, and that's what seismologists read. So it's a lot of seismic things. Okay. Then there are things called the magnitude scales. So there's a Richter magnitude scale, and it was invented first. And it's not very accurate for things, below 3.0 or things above 7.0. But then there's the moment magnitude scale, which is probably more accurate. And what it is if I get back to the rubber band scenario, so when you're stretching it and it let goes, this measures how much energy was released when it snapped. And so that's what happens when there's an earthquake. And so that's how you know how big it is. So then this is like the most, you can apply it to your real life. It's earthquake hazards and safety. So the most common hazard is fire. And fire is basically like when there's a gas line or like something, or electrical line, something that's very flammable. It catches on fire, and when it catches on fire, then other things catch on fire, and it becomes a huge thing. And then there are landslides, which are basically, everybody kind of knows what landslides are. It's just when something's at a slope, and then the things at the top start rolling down. It's kind of like a big snowball, and it gets worse and worse. And if you're at the bottom of a huge hill and everything comes rolling down, then you will not be happy. Then there's liquefaction, and that's the kind of complicated one. It's when there's loose fragments like sediment, and it like kind of turns into something like mud, and it starts moving like a liquid even though it's a solid. And so then you can see, like, when it hardens, you can see it looks like water. And the big and worst one is tsunami. And tsunamis are really the worst. Just imagine a huge wave, and it's incredibly scary for everybody. They're huge tsunamis that have affected a lot of people. So basically, tsunamis are kind of interesting. So what happens is there's an earthquake, and the land moves down like that. So it's right here instead of right here. And even though that's like only a meter, and like anyone would be like, that's no big deal, it's a huge big deal because all of the land starts going like this. And so it's a huge fast-moving wave, but it's smaller than a regular wave when it's in the deep side. But as the water gets shallower and shallower, it becomes this huge wave, huger than like 3 houses stacked together. So it's like this huge dangerous thing that's really hard to live through. And if you want to avoid the earthquake hazards, you probably just want to be like safe buildings that are sturdy, not like a ton of stories, and like don't be along faults, because that's where earthquakes are most happen to. And of course, don't after an earthquake say, oh, it'll be a good time for the beach, and get hit by a tsunami. That would not be very good. That's basically it. They're just like earthquake safety kits. You can buy them on Amazon. They're just like bandages, food, water, blankets. That's it. That's probably only the basics that you need to know, and as long as you know that, you'll probably be good for whatever test you're studying for. So